Hello, everyone. Thank you all for being here. My name is Alexandre, and I'm here to talk about creating and maintaining ephemeral runtime environments for 18,000 developers. First, let me introduce myself. My name is Alexandre Astolpho Thomaz. I'm from São Paulo, Brazil. I've been a software engineer since 2004. I work at Itaú Unibanco since 2011, and I've been Kubestronaut since 2025. Second, let me introduce Itau. With over 100 years of history, we are the largest bank in Latin America. It's our ability to adapt, innovate, and transform that has allowed us to get here. We operate in 18 countries. We have a market value of over $74 billion. We are the most valuable brand in Latin America, and 97% of our interactions with individual customers are digital. Itaú is on a modernization journey, and our modernization strategy is focused on delivering value to customers while ensuring sustainability and competitiveness. It started with on-premise a little time ago. Then we adopted private cloud in 2018. And finally, we started moving to public cloud in 2020. It's important to mention that Brazil's central bank regulated the use of public cloud by banks in 2018. And highlighting the outcomes so far, we achieved 50% of our business services in the cloud by the end of 2022, 65% by the end of 2024. And we have the goal to have 100% by the end of 2028. And we are at this point today. So what we have done so far? Over our transformation journey, we integrated multiple disciplines like design, technology upgrade, product methodology, and data. We combined method and artificial intelligence, and always focus on quality, efficiency, speed, and hyper-personalization. All this together, with our customer-centricity purpose, led us to some outcomes. 99% of reduction in high-impact incidents, over 2,000% of increase in technological change and updates, and a 45% of reduction of costs in transactions. It's important to remind you that our target is to have 100% of the bank's platform modernized and running in the cloud today, by 2028. And we still have a lot to overcome. But can this approach be maintained over time? When we look at the amount of resource that we have to maintain, we have these big numbers. We have hundreds of thousands of Git repositories, hundreds of thousands of databases, tens of thousands of public cloud accounts, thousands of Kubernetes clusters. Okay, you may think, well, at least the developer is happy and focused on what matters, right? No. The developer experience needs some improvements too. We have outdated process with lots of service tickets. The battle between tech and business for backlog prioritization, and the amount of toil. With this scenario, we decided to adapt and rethink our approach. So we created our platform following these 4 tenets: developer journey, product experimentation, standardization, and runtimes. Developer journey. So we need to establish some golden paths for the developer to enable velocity with quality and security, while focusing on delivery business value. Product experimentation. The business need for the ability to experiment is crucial. Enabling new ideas quickly can minimize risk while using feature flags capabilities, A/B testing, among many others. All of these capabilities with the telemetry and usage data enable better decision-making. Standardization. We need standards for being able to create the most automated environment ever. We also need a faster local development environment using predefined stacks. So we created three: front-end stack, a back-end stack, and analytics stack. And we need standard building blocks propagating the use and reuse of components. Those building blocks implement authorization, authentication, observability, messaging, database, events, and many others. And runtimes. We need a fast, reusable, and pretty much standard data plane environment that could deal with the business technological needs while supplying resilience, observability, and the flexibility that the application needs. Okay, you could be thinking, great, but how you did it? We can see here a big picture that represents our platform. The three important roles here are the control manager. It's a robust control plane that acts as a multiple control planes orchestrator. The control planes. They are responsible for maintaining a particular technical capacity working. And the data planes. This is where all the actions happens. All the applications, resource, and data get together to work as reliable as we need. The strategy behind the control manager is to have the most reliable platform, so we adopt these pillars. We used a cell-based architecture with a multi-tenant strategy in a multi-cloud environment. It is Kubernetes-based, and all services are built using Golang. And what about the control planes? The control planes have distributed missions, so we have a separated control plane for database, another one for messaging, and another one for applications, to name a few. All the control planes follow the same design pattern, and as you can see, it is a lot based on a Kubernetes control plane, with the API server, a scheduler, controllers, some state store, and many others. The pillars for the control planes are, they are distributed, multi-tenant, Kubernetes-based, they use the Argo stack, they use cross-plane, and Golang. When I say flavored cross-plane, we mean that they are specialized providers for the control plane purpose. For example, as we can see here, we have the application control plane with Kubernetes providers and also some custom app providers. And in the database control plane has this SQL database and the NoSQL database providers. Last but not least, we have our data planes. To ensure that we are on the same page, this is a data plane account for application, and this is a data plane account for database. Let's talk about the ephemeral data plane, or as we can call them, runtimes. I'm going to explain more about the application data plane because it's the focus of this session, but it's important to notice that each data plane account is responsible for only one type of resource. For example, a data plane account for containers on a Kubernetes cluster, or a data plane account for databases, and another data plane accounting for messaging. The main pillars of the data planes are, they are stateless, isolated, elastic, on demand, and they have their lifecycle automated. Let's focus on the application data plane. It has multiple Kubernetes clusters. Each cluster has multiple namespaces containing each one its own business service. And each namespace has everything it needs for the business service to work. Okay, let's see more detail about the runtime. First, let's make sure we are aligned on a few definitions. Business service. For us, business service is a group of business offerings. And what's a business offer? It's a simple action like make transaction, get all information from customer X, transfer funds, check balance, many others. They are usually exposed by API. They have their business health metrics by default, and they are namespace scoped. Runtime main functions they are Kubernetes cluster with standard deployment strategy, observability, and policies. And the namespace is an all-in-one business service with mesh and backup and restore capabilities. Let's talk about the runtime implementation. So this picture has a good view of our implementation of a runtime, which is important parts. We are using Kong for API gateway, OPA for policy, the Argo stack for deployment management, Helm for package management, Datadog for observability. And inside the namespace business service, we have ECO for service mesh and Velato for backup and restore. So for everything to happen, we have some core actions at the control plane. Remembering the flow of commands, the control manager is responsible for orchestrate the control planes. So in the application control plane, we have both commands for runtime and application operations. For the runtime, we have mainly create, destroy, and drain a runtime. The ability to drain a runtime is similar to what happens inside Kubernetes while draining a node, with some important details related to business service availability. And for the applications, we have mainly deploy, relocate, and destroy. So let's see a basic use case first. Let's create a runtime. The API server receives a command to create a new runtime. Then the scheduler is responsible for finding the best data plane account to place the new runtime. After identifying the best data plane account to place it, the control plane commands the creation of the runtime using Argo and crossplane. While creating the runtime, the control plane expects a health check validation. Until the runtime responds with valid health check, the control plane doesn't recognize its existence. So great. Let's get another use case. This time, one related to applications. Here, we get the business service deploy. It starts again with a command at the API server. Then, the scheduler finds a spot to place the business service. As you can imagine, we use the Argo and crossplane to deploy the business service at the spot defined. If there is no spot available, the control plane creates a new runtime as seen in the previous slide. Okay, but what about cluster management? We have the runtime maintenance use case. This is a level hard automation, so we have some critical steps here. It starts again with a command at the API server, requesting the maintenance of a runtime. Let's say, for example, the runtime X. As we can see, there are some business services currently allocated at the runtime X. That's a problem for us. We need to relocate those services. First, the control plane sets the runtime status as maintenance mode. This is needed even if the runtime didn't have any business service. The maintenance mode stops any activity in the runtime. Then, the control plane starts to relocate the business service at available spots in other runtimes. In the example, there is only one spot and two business services. The control plane decides to create a new runtime and gets waiting for a new spot to be available. Then, the control plane places the remaining business service at the end of runtime at the new runtime created. And at last, it destroys the original one. Okay. Searching for excellence in orchestration runtimes, these are some of the best practices that we have learned so far. Make it stateless. The importance of automation and observability. And of course, keeping an eye on resource and cost management. And also things related with reliability like performance, scaling, and design for failure. And I don't even need to mention about security and compliance. But I want to highlight the immutability. Put some extra effort on trying to enforce immutability. Sometimes it seems to be faster to update some configuration in place, but the maturity that you obtain with the pursuit of immutability enables many important things in your control plane. So we talk about best practices. Now let's see some important metrics for you to run and operate your runtimes. Keep track of metrics for your runtimes is essential for several reasons. Metrics give you a clean picture of how your runtime is performing. You can think of performance optimization and deal with capacity planning, and also deal with cost and resource optimization. The main groups of metrics are startup and life cycle, so getting the startup time, the teardown time, the duration, resource utilization, performance and scalability, reliability, and observability. Let's keep in mind that we are talking about the runtime itself, not the applications runtime, the applications running in the runtime. Okay. Wrapping up. To make a long story short, we started with these pain points without a platform. To name a few pain points, much time and effort on an outer loop, the increase of toil, slow feature delivery, hard to maintain, resource inefficiency, and operational overhead. And as you could imagine, it was not a sustainable scenario. And with platform, we ended up addressing them with our tenants strategy, focusing on delivery journey, product experimentation, standardization, runtimes. With the pain points resolved, here are the outcomes that you can expect. To have a unified developer journey with cross-functional collaboration. You have team working together from ideation to deployment. Empowering teams with a consistent platform experience. So a reliable platform can enable both developers and business teams on creating more and more business value. Cost optimization through shared ownership. The importance of connecting both developer and business owners to address business sustainability. Scalable solutions driven by business needs. Here, we can watch the power relation between business demand and technology scalability. And flexibility to innovate across domains. So the ability to address several use cases from the smallest prototype to the highest performance application demand. To conclude, keep in mind that platform engineering is more than technology. It's a journey of learning, growth, and building the foundations for what's next. See you on next chapter. Thank you.